Hello friends, in this video we are going to derive the parameters related to the buck boost converter. Okay, so in the last video we have already discussed about the circuit operation and some of the parameters. So next, the ripple in inductor current. Okay, ripple in inductor current. Okay, so suppose in order to find the ripple in inductor current, ripple in inductor current, ripple in inductor current, that is nothing but the ripple in IL. Okay, so if you check here, the current IL during t on is changing from I min to I max. Okay, so the ripple in inductor current is nothing but the delta IL, which is equal to I max minus I min. Okay, I max minus I min. So here during t on, right, during t on means what? When the switch is in the on state, right? So when switch is in the on state, so can we apply KVL to this loop? Yes, KVL to loop 1, KVL to loop 1. So we can write it as plus VDC, right, minus VL. VL is nothing but the L into DIL by dt is equal to 0. Okay. So from this we can write it as VDC is equal to what? L into DIL means what? Change in the current, inductor current, right? So we know the inductor current is changing from I min to I max. Okay. So what is the change in inductor current? It is I max minus I min. Okay, I max minus I min divided by dt. Dt is nothing but the t on minus 0. So it is a t on minus 0. Okay, so therefore we can write it as, yes, VDC into t on minus 0 is the t on, right? And if we shift this t on to this side, so it is like a dt divided by L is nothing but I max minus I min. And this I max minus I min is nothing but the delta IL, right? Is nothing but delta IL. Are you getting the point? Okay, so it is a VDC into dt by L. Okay, further can we replace this VDC, that is a input voltage, okay, in terms of the output voltage? Yes, we can write it as 1 minus d. Okay, so therefore further we can write it as delta IL is equal to, we are going to replace this VDC, right, with 1 minus d by d. Okay, so is equal to 1 minus d by d into V0. Okay, into this dt by L as it is, dt by L as it is. So dd will get cancelled. So therefore ripple in inductor current, that is nothing but the delta IL, yes, is equal to, yes, it is 1 minus d into t divided by L, right, into V0, into V0. This is the ripple in inductor current we are having. Okay, that is nothing but the delta IL, that is nothing but delta IL. Is this clear? Okay, so next, I max, peak value of inductor current, peak value of inductor current, right, is equal to, we can write it as a IL max also, IL max also. Okay, so if you check the peak value of inductor current, yes, it is equal to IL average, IL average plus delta IL by 2, right, delta IL by 2. This is the delta IL, and delta IL by 2 means what? This is a 50%, right, means from here to here this is nothing but the delta IL by 2. Okay, so you can write it as I max is equal to IL max is equal to, yes, IL average, IL average plus delta IL by 2, delta IL by 2. Okay, similarly can we write I min is equal to what? IL min, I min is equal to IL min, right, is equal to what? IL average, okay, minus delta IL by 2, minus delta IL by, okay, so this is the IL min. Okay, next can we write the IS average, supply current average value, IS average, okay, which is equal to average value of source current, average source current, average source current. Okay, so if you check, so we can write it as a IS average, okay, is equal to, okay, so if you check, when switch is in the on state, at that time IS and IL both are same. When switch is in the off state, IS will be 0. Okay, so roughly can we draw the waveform for the IS? Yes, it will be like this, IS. Okay, this is the time. Okay, 0. Yes, strictly speaking this waveform should be I min to I max, right, I min to I max, this type of waveform it should be there. Okay, during 0 to dt, that is a t on, during t on to t it is a 0, and after that again it will be same cycle repeats. Okay, so this is like a I min, and this is like a I max. Okay, I max. Further, approximately we can write it as, yes, what is the average of this? It is a like IL average. Okay, so we can write it as IS. Okay, and this is time t 0 to dt. This is like a IL average. Okay, this is IL average. Are you getting the point? Into dt, and further from dt to t it will be 0, and again it will be same as that of IL average. Are you getting the point? Okay, so further for this will be again same as that of the IL. Okay, next this is dt to t. Now can we find the average value of this? Yes, we can find it as 1 by t integration from 0 to dt. It is IL average into dt. Okay, so we can write it as is equal to, yes, d into IL average, right? It is like a 1 by t into IL average into dt. So tt will get cancelled. So is equal to d into IL average, right? D into IL average. But what is IL average? IL average is d upon 1 minus, sorry, IL average is equal to, we are having, it is a 1 upon 1 minus d into I0, right? 1 upon 1 minus d into I0. So you can write it as d into 1 upon 1 minus d into I0, right? This is the IL average we are having. Are you getting the point? We already derived this in the last video. Okay, so it is like a I0 average, or you can write it as I0 also, because we assume that the I0 is constant. So it is a d upon 1 minus d, okay, into I0 average. This is what? Source current average value, IS average, right? IS average. Next, now source current average value. Okay, next, further we can write IS RMS also, right? IS RMS also, right? So RMS value of source current, RMS source current, RMS source current. We can write it as IS RMS, IS RMS equal to what? 1 by t integration from 0 to dt. It is IL average square into dt, right? To the power 1 by 2. Okay, so this can be written as 1 by root t into IL average. Okay, IL average, because IL average is constant, so I am taking it outside. Okay, into under root dt. So this t and this t get cancel. Okay, so under root d into IL average. Okay, so or we can write it as under root d upon 1 minus d, under root d upon 1 minus d into I0 average. Okay, this is nothing but what? IS RMS, RMS value of source current, right? RMS value of source current, right? Next, now can we find the ripple in output voltage or capacitor voltage? Ripple in, ripple is nothing but change. Okay, ripple in V0 or VC, V0 or VC. Okay, so if you check, the capacitor is charging and capacitor is discharging. Okay, so therefore the capacitor voltage is, even though, yes, we assumed it as a constant, but actually it is a not constant, right? But the switching frequency is high, so due to that we will be observing it as a constant. Okay, so now if you check during 0 to t on, yes, capacitor is discharging. Okay, during 0 to t on, when switch is in the on state, the capacitor discharges. Okay, so at that time what is the IC? IC is equal to minus I0. Okay, so if we take IC into dt, right? If we check IC into dt, that is nothing but the charge, right? That is nothing but the charge. Okay, so we can write it as ripple in capacitor voltage or load voltage, that is the VC or V0. Okay, is equal to, we can write delta V0 is equal to delta VC is equal to what? Delta Q by C. Okay, as well as C is equal to Q by V. Okay, so therefore delta Q by C. Okay, so what is the delta Q? If you check delta Q, that is the charge stored or the charge released, right? Is nothing but it is a current into time. Okay, so therefore we can write delta V0 is equal to what? Delta Vc is equal to delta Q means what? It is a time, that is a on time, into what is the current, that current is I0, okay, divided by C. Okay, so we can write it as, therefore delta Vc is equal to delta V0 is equal to dt into I0 by C, dt into I0 by C. Okay, this is the ripple in capacitor voltage, that is a change in the capacitor voltage. Are you getting the point? Okay, so this is about some of the parameters related to the buck boost converter. In the next video, we'll discuss some other parameters related to the buck boost converter. Thank you.